For some data, it doesn't always make sense to make a frequency distribution where we leave each individual value in that first column. And in these cases, we can make what we call a grouped frequency distribution where rather than listing the individual values, we're going to list intervals. And the basic rules are we make sure each interval, which we call a class, will have the same width, so the same interval length. Make sure that classes don't overlap because we want to make sure that each individual data value will only belong in precisely one interval or one class. When it's convenient, it can be advantageous to have an even class width or interval length. And after we're done making a grouped frequency distribution, often, and we're going to be getting into calculations a little bit later, but it'll be helpful to have a particular value where we say that one value will represent the entire interval or the entire class. And in this case, we always use the class midpoint as this value. So in example 10, let's make a grouped frequency distribution. Here's a list of 50 exam scores. They're already in increasing order. We're going to construct a group frequency distribution with a class width of 10, and we're going to start with that interval right there. So when we make our frequency distribution, I'm going to have my class, which is the interval. The first class they gave to us, 35 less than or equal to x less than 45. Pay attention to how we're writing this inequality. This interval right here includes the 35 but goes up to not including the 45, and we're going to pick that up in the next interval. So 45 less than or equal to x less than 55. And then keep going. That may seem a little bit odd that we're allowing these values to go up to 105, given that it is an exam score. But it is fairly important that we have our classes all be the same width. And now, in the other column, we're going to list the frequency. And usually, in these frequency distributions, we'll abbreviate this with just a lowercase f. So let's do some counting here. 35 to 45. We just have two scores there. 45 to 55 will encompass just these two. Remember, the 55 is not included in this one because it's strictly less than. The 55 is picked up in this next row. 55 to 65 is going to start here and end here. So that's 1, 2, 3, 7. 65 to 75. Start here and end here. That's 13. 75 to 85. We'll pick up here and end here. That's 11. 85 to 95 starts here and ends here. That's another 11 scores in that interval. And then lastly, 95 to 105 picks up these last four. So here's a group frequency distribution, and if we like, it will come in handy later on. We're going to distinguish a value, that singular value, to represent each class. And so, as I said before, we're going to use the midpoint. And in any formulas, when we start doing calculations, this midpoint value, this is what we're going to let our x be. So it's going to be a singular data point to represent the entire class. We're just going to use the midpoint. To find the midpoint of an interval, just add the two boundaries together, 35 and 45, and divide by 2. and that'll give us 40. Now, of course, each of these classes is the same width, and so that means the midpoints are going to be that width apart. They're each going to be 10 apart, so we have 50, 60, 70, 80, 90, and 100. You can, and there's some exercises that may ask you to do this. This is really kind of, I'd say, optional, I guess unless you're specifically directed to do so, but some people choose to include the relative frequency. And a relative frequency, the relative frequency is simply given by, you take the frequency of each value and divide it by the total number of scores. And you can express it as a fraction, as a decimal, or as a percentage. So in this first row, the frequency is 2. There are 50 exam scores here, so n is equal to 50. And so we've got 2 over 50 for the first row, and that's 0.04. And the same thing for the next row. Next we have 7 over 50, which is 0.14. 13 over 50, 0.26. 11 over 50 is 0.22, and we have another 11 over 50 is 0.22, and 4 over 50, 0.08. So here's our grouped frequency distribution, where we've also indicated the midpoint value for each row as well as the relative frequency.